Hello, everybody. We're going to construct a circumcenter today. So you're going to need your unit notes packet out. We are going to be on, what page is this? This is page 5 in your notes packet. You want your compass, you want a ruler, and you want a pencil. So pencil, compass, ruler, and then your notes packet. And you might as well have your homework packet out as well, because I will talk about that too. All right, so let's get started. Constructing a circumcenter. I wonder what a circumcenter is. Let's find out. So this says construct the perpendicular bisector of AB, BC, and CA on the triangle below. After you constructed all 3 bisectors, describe what you notice. Okay, so we're starting out with the same construction that you learned previously, which is a perpendicular bisector. So I'm going to get my compass, and I'm going to make a perpendicular bisector of all 3 sides. I don't know why this is jumping. There we go. All right. And to make a perpendicular bisector, I'm going to start with BC just because it's on the bottom. I want to open more than halfway. Okay. And I'm going to draw one arc here. And then another arc down here. And then I'm going to connect the dots with a straight line. There's the perpendicular bisector of BC. Now I'm going to do that again for AB. So I'm going to change my color. Now, unfortunately, you don't get to change colors on your compass. I do, but you're going to have a lot of arcs going around. So just make sure you're paying attention to what you're doing. So now I'm going to construct the perpendicular bisector of AB. So I want to open more than halfway, about 3/4 of the way down AB. And then I'm going to draw 2 arcs for this one. That one and this one. And then I'm going to connect the dots again. And this time what I'm going to do is I'm going to extend it until it crosses the other one. Okay. So I have a longer perpendicular bisector. All right, that's good. And then last but not least, let me change to blue. And I'm going to find the perpendicular bisector of AC. So I'm going to open my compass more than halfway. And I'm going to draw 2 arcs. 1 and 2. And then connect the dots here. Ooh, that worked out beautifully. What should happen, depending on how good you are with your compass and if it wiggled a lot, is your 3 perpendicular bisectors should all intersect at the same point right here. Okay? That point right there is called the point of concurrency. Okay, we'll call that P. That is called the point of concurrency. And I'll explain what these things mean in a minute. And in this case, it is called the circumcenter. All right. And that's what we're learning about today. So let's scroll down and talk about what these things mean. What are concurrent lines? That is 3 or more, or more lines intersecting at a single point. 3 or more lines intersecting at a single point. That's what concurrent means. And the point of concurrency, or the intersection of the concurrent lines of the perpendicular bisector, is called the circumcenter. Okay? And we call that point P. Now, the next thing we're going to do is, why do I care about where these intersect? Here's why. We're going to put our compass point on P, put the pokey part on P, and then you're going to open your compass. I'm going to scroll up a little bit and go from P to C. Now, I'm not going to draw anything yet. So if I open from P to C, that's one distance. If I move this over, well, bam, P to A is exactly the same distance. Bam, P to B is exactly the same distance. Now I'm going to draw a circle. And what should happen, or at least be very close, is that the circumcenter is equidistant from each vertex. If you draw that circle, it should touch every vertex. Now notice mine isn't perfect, and that's okay. But we want it to get as close as we can here. All right, so put compass point P and the pencil on any vertex, draw a circle. What do you notice? The circle touches every vertex. And the circle drawn is called a circumscribed circle because it touches every vertex of the triangle. So, what have we learned so far? We've learned that when you draw perpendicular bisectors in a triangle, where they intersect is called the circumcenter, and the circumcenter is equidistant from each vertex. So I kind of want you to put that down here on the bottom. Is perpendicular bisectors of a triangle lead to the I can't write neatly today. Circumcenter, which creates the circumscribed or outside circle. Okay. All right, get that jotted down. And then we're going to turn the page. Now it says, we're going to explore this thing on GeoGebra. Is it ever possible for a triangle circumcenter to be outside of the triangle, on the triangle, inside the triangle? So we're going to take a peek at this next thing right now. So I want GeoGebra. I got to pull this up here. Whoop. And this is just going to be a little applet. Okay. And what this is it's going to let me drag things and show me the circumcenter. So let me make it bigger. So this right here is the circumcenter. And I know it's the circumcenter if I connect from the center to point L, it touches L, J, and K. Now, watch what I can do with this. I can take this triangle and move it. Whoops, I didn't mean to do that. There we go. I can take this L and move it, and the circumcenter in the triangle moves with it. Okay, so watch this. If I do this, that circumcenter is in the center, just like I would expect it. But watch now. I want you to watch this angle right here. Watch the red angle. So as I move this, see that red angle? It's changing. Now watch what happens. I'm going to bend this upward. See the red angle? It's growing. Now I want you to look at the red angle and point C. As the red angle grows, point C is moving toward the edge. And if I grow perfectly to 90 degrees, it's always so hard for me to get exactly 90. Come on. A little bit smaller. I can never get it. But anyways, if I could get to exactly 90, which I'm terrible at getting to, this point C is exactly on the edge. And once I grow above 90, C is outside. So if we go back to our notes, is it ever possible for the circumcenter to be outside? Yes, when the triangle is obtuse, meaning it has one obtuse angle. Is it ever possible for the triangle circumcenter to be on the triangle? We had that happen too, yes. When the triangle has a right angle, it is a right triangle, pardon me, hiccups. And is it ever possible for the triangle circumcenter to be inside? Yes. When all angles are acute. Okay. So circumcenters can move inside and outside. They are outside when you have an obtuse triangle, inside when you have an acute triangle, and if you got a 90-degree angle, it's right on the edge. Okay. And then it said, on the applet, construct the circumscribed scribble C. Okay, so let me go back to the applet here. Now they want us to measure from C to K, and that's 6.2. C to L, oh, that's 6.2. C to J, that's 6.2 also. So what we just learned is the distance from C to any vertex is always going to be the same. And even if I move this around, look at how those stay the same. So no matter what I do, these three lengths are going to stay the same. Oops, went too far. So on the applet, construct that, complete the generalization. The distance from the circumcenter to the vertex is the same for every vertex. And in a shorter context, that means a triangle circumcenter is the only point that is equidistant from each vertex of the triangle. Okay, now grab your homework packet, and I want to quickly talk about the homework for this. So in your homework packet, I want you to go to the day 2 homework, which starts on page 4. Number 1 says, construct the circumcenter. Well, we just learned that that's where the perpendicular bisectors intersect. But, fun fact, since all 3 are going to intersect at the same point anyway, you really only need to construct 2 perpendicular bisectors and see where they meet. You don't need all 3, because if all 3 intersect at the same point anyway, 2 is good enough. So if you need a circumcenter, you can construct 2 perpendicular bisectors and see where they cross. Then the next one says, circumscribe a circle around the triangle. Well, the only way for us to do that is step 1, to find the circumcenter using 2 perpendicular bisectors. And then 2, draw a circle with the center or the pokey part on the circumcenter and your pencil on a vertex, and then you will draw a circle around the outside. Okay? Don't do this. I'm sketching, but what I'm really telling you to do is make 1 perpendicular bisector, bam. Make another perpendicular bisector, bam. These will intersect somewhere. Fun fact, they should intersect on the edge. Mine's a little bit off. And then with your compass, you're going to use this as the center, put your pencil on an edge, and you should be able to draw a circle that goes around like that. Don't do it that way. Use your compass. Mine's just to show you what you should look like when you're done. All right. Then we have the Smith Construction Company. Same thing, make a circumcenter. This one is asking you which point is the circumcenter. And if you want to know which point is the circumcenter, I would probably make 2 perpendicular bisectors and see where they cross. Last but not least, I want to talk about this. In this diagram, these are all perpendicular bisectors, and they meet at the circumcenter, and then they give you a bunch of distances, and they say find the indicated measure for each. What I want to do here is when you do this, if these are perpendicular bisectors, that means that these are all 90 degrees, and that this equals that, and this equals that, and this equals that. And if this is a circumcenter, pardon the beep, if this is a circumcenter, that means the distance from G to any vertex is going to be the same. So these 3 blue lines all have the same length. which is 25. All right, there's a lot to unpack there. You have to do the practice. Do the practice and you will be okay. Let me know if you guys have any questions on anything that I just did. All right, have a wonderful rest of your day.